Hey everyone, we are the Unbiased Media Group. And as a quick introduction from left to right, we are Ryan Lamb, Matthew Carter, Sam Smith, and Gates Lamb. And speaking is Gates Lamb. So the problem that we set out to tackle for our capstone project is to determine if we can help users or readers of news and articles in general determine if there's any type of biases within the articles that they're reading or that maybe they want to read. So as you can see here on the left, that's a pretty blatant example of some type of bias, right? The alt-right sage without the rage. That title in and of itself really throws the article in one way or another. But there is a little bit more subconscious bias within the articles as you dive deeper into it. This bottom right sentence, shaken by his especially foul mood. We might just read that and think that Trump was shaken by his especially foul mood, but that does in some way maybe subconsciously throw the article again in one way or another. So the solution that we created was to we built a Chrome extension that currently supports about 75% of the most viewed or most popular news outlets here in the US. So when a user with our Chrome extension goes to an article that they are either reading or want to read, our Chrome extension is going to automatically start scraping the content of that article, the words and the sentences, and it's going to send it back to our backend to be analyzed with machine learning to determine if that article has any type of biases in it and how much biases, and we'll provide an overall rating for that article. Now we realize that, hey, once we're reading the articles, we actually are gathering information about specific authors and outlets as well. So we provide overall bias ratings on authors and outlets too, again, utilizing machine learning. And then we wanted to hone a little bit more into the biases themselves. And so we decided to rate the articles based off of how much spin, emotion, and opinion they have as well. We also have some cool features like individuals being able to favorite articles, and then also being able to consolidate global favorites from all of the users using our system. So with that, I'm going to pass it off to Matt Carter to dive into a demo of our Chrome extension.
All right, so let's look a little bit into how the Unbiased Media Chrome extension works. So first of all, you'd start off by going to a news article, such as this Economist article, and you'd think, I wonder if this article contains bias. Well, to look at that, you would go over and you'd click on our Chrome extension in the top right corner, and this will pull up some information about this article. In the background, we're going into this article, pulling all the data, sending it to our neural networks, which is then crunching the data and returning these scores, which you see here. In the middle of the section, you can see our overall score. This is ranked on a good, moderate, or poor scale. And you can see the overall rating here. Down below, we have our bias category score. This is of the bias sentences we saw, which of these sentences have spin, which of these have opinion, which have sensation or emotion. And the percentage also represents that score. Here, you can also favorite articles. If you think this article is really unbiased or whatever, you can favorite it so you can look at it later. Another important feature is the ability to highlight bias sentences. That's what this is. This lets you see of the sentences in the article, what did we consider biased and what contributed to the score. If you go back into the extension, you can also drill down these scores into separate authors and outlets. These are aggregates of our article rankings. And here you can see that this author, corporate author of The Economist, is also ranked as marginal. This is the same for the outlet. You can also favorite the authors and outlets separately from articles. Continuing on, you can click on My Favorites, and this will let you see all the articles, authors, and outlets you have favorited, let you manage them and delete them. Additionally, we also have global favorites. This is kind of a ranking of the articles, authors, and outlets as favorited by our users. So if a lot of our users are favoriting, for example, The Economist, as you can see here, or Michael Lee, the author, this will show up in our global favorites. You can also click on authors and outlets, and this will show recent articles that we have ranked from this author. We can also then move on to supported outlets. Each outlet or news agency, for example, the New York Times or CNN, requires custom scrapers and that we can pull this text in and rank. This shows you which outlets we have built in this are supported. We have 36 right now. You can see them here. We also have some additional functionality, for example, feedback. This lets users go and gives them a random selection of sentences from this article and lets them rank them as biased or unbiased. This contributes to our overall scores and helps us retrain our models by pulling in kind of some crowdsourced feedback. Lastly, we also have our statistics server. So with all of our users ranking all these different articles, we pulled together a lot of different interesting statistics here. So if I click into that, you'll be able to see some of these statistics. This is on our own website. And this drills down a little bit into, for example, outlets, their average and aggregate scores, and the same for authors. So that's a little bit about our unbiased media Chrome extension. Thanks for listening.
Hi, I'm Sam, and I'll just be talking a little bit about how we put this project together and the technologies we used. So the Chrome extension communicates with an EC2 server that we built using the Django framework. And so we use the Django framework just to develop all of our APIs for front-end, back-end communication. And so basically, when the Chrome extension sends article text to the backend, the Django server will just call our machine learning model that we built out using PyTorch. Then we get those scores out of that and store them in a MySQL database, and then send those scores back to the front end. And if a user ever using the Chrome extension visits an article that we've seen before, we don't have to call that machine learning model, and we can just go straight to the MySQL database and fetch those scores and send them back to the front end. And that's about all we have for you. So thanks for watching. Some acknowledgements we'd like to make are we just want to thank the professors, James St. Germain and David Bean, as well as the TAs, Adam Vogel and Ayushi Sharma, for helping us out our senior year and helping us build this project. So thank you to them, and that's all we have for you.